Hi everybody, it's Professor Mitchell. We're continuing Chapter 8 on algebraic thinking. And today we're going to talk about Section 8.2, equations. In this section, you'll be able to understand and explain properties of equality and equations, solutions of equations using properties of equations, and solutions of word problems. So first, let's review the properties of equality. We've talked about these before and we've used them. First one says for any real numbers, a, b, and c, if a equals b, then a plus c equals b plus c. So in English, what this says is that you're allowed to add any real number to both sides of an equation and you get an equivalent equation. And you can also multiply both sides of an equation by any real number. For any real numbers a, b, and c, if a is equal to b, then a times c is equal to b times c. Now these properties are really just the same thing. They're calling them by a different name. They're calling them the cancellation properties of equality because that's kind of how we use them. First one says for any real numbers a, b, and c, if a plus c equals b plus c, then a equals b. And the way we usually use this is subtract a number from both sides of an equation. And the next one says for any real numbers a, b, and c, with c not equal to 0, that's important. If a times c is equal to b times c, then a equals b. And the way we usually use that is by dividing both sides by a real number. The balance scale model is an excellent way to foster understanding of the basic concepts used in solving equations and inequalities. And equations can be explored using a balance scale. Inequalities tilt the scale. So here's an example. On one side of the scale, we have 2 times 3, which is 6. On the other side of the scale, we have 3 plus the product of 2 and 2, which is 7. So if the pan on the left is released, the scale will tilt down on the right side, and that represents an inequality. However, in this example, we have 2 times 3, which is 6, and 1 plus 1 plus 4, which is also 6. So if the pan on the left is released, the scale will balance. So in this case, we have an equality. In this example, we want to find some solutions for the variables that will keep the scale balanced. So on one side, we have 3 times square, so 3 times some mystery number. And on the other side, we have 2 times triangle, so 2 times some other mystery number. Well, one possibility is to replace the square with 2 and the triangle with 3. That would give you 3 times 2 and 2 times 3. Another possibility is to replace the square with 4 and the triangle with 6. That would give you 3 times 4 and 2 times 6. In this example, we want to solve for x. On one side, we have 3x minus 14. On the other side, we have 1. So using the balance scale model, we'll start by adding 14 to both sides. That's an example of the addition property of equality. So on this side, we have 3x minus 14 plus 14. On the other side, we have 1 plus 14. That simplifies to 3x on the left side and 15 on the right side. And then if we divide both sides by 3, using what they call the cancellation property of equality, on the left side we have x, and on the right side we have 5. So x must equal 5 if this scale is balanced, if this is an equation, an equality. All right, here are some examples, and we'll do these without the balance scale model. First example is x plus the cube root of 4 equals 20. We'll start by subtracting the cube root of 4 from both sides. And that gives us x equals 20 minus the cube root of 4. And believe it or not, at this point we're done. 20 minus the cube root of 4 is a perfectly good real number. Next, we have 3x equals x plus the square root of 10. We'll start by subtracting x on both sides. That gives us 3x minus x equals x plus the square root of 10 minus x. And now if we simplify each side, 3x minus x is 2x. And these at the x minus x cancels and just leaves us square root of 10. If we divide both sides by 2, we get x equals the square root of 10 over 2, which is another perfectly good real number. Next, we have 4x plus 5x equals 99. Maybe we should have started with this one. All right. 4x plus 5x simplifies to 9x. And if 9x equals 99, that must mean x equals 11. This one is kind of similar to letter C. It's just that instead of having x's, we have x plus 3's. Now, the way they do this problem is one way to do it. It's not the only way. I could see somebody doing this a different way. They noticed that these x plus 3's are exactly the same. So we can actually combine these two expressions. Think of this as 4 apples plus 5 apples just gives you 9 apples, all right? 9 times x plus 3 equals 99. And because 99 is divisible by 9, we might as well divide both sides by 9. That gives us x plus 3 equals 11. And now if we subtract 3 from both sides, we end up with x equals 8. You might want to try that problem a different way. If you were thinking about doing it a different way, you should get the same answer. There's not always just one way to do these. All right, that brings us to the ever popular word problems. Bruno has 5 books overdue at the library. The fine for overdue books is 10 cents a day per book. He remembers that he checked out an astronomy book a week before he checked out 4 novels. If his total fine is $8.70, how long was each book overdue? So we'll start by understanding the problem. Bruno has 5 books overdue. He checked out an astronomy book 7 days earlier than the 4 novels. So the astronomy book is overdue 7 days more than the novels. The fine per day for each book is 10 cents, and the total fine was $8.70. We need to find out how many days each book is overdue. So let's call D the number of days that each of the 4 novels is overdue. Remember that the novels are overdue a different number of days than the astronomy book. So D can stand for the number of days that the novels are overdue. The astronomy book is overdue 7 days longer, which means D plus 7 days. The total fine is $8.70. This fine in cents equals the fine for the astronomy book plus the fine for the 4 novels. The fine for each of the novels is the fine per day times the number of overdue days. The fine per day is 10 cents. The number of overdue days we're calling D. So the fine for each of the novels is 10D. The fine for all 4 novels is 1 day's fine for novels times the number of overdue days. So that's going to be 4 because there are 4 novels times 10D, which is the fine for one of the novels. So the fine for all 4 novels is 40D. The fine for the astronomy book is the fine per day times the number of overdue days, which is 10 times D plus 7. The fine for the novels plus the fine for the astronomy book is equal to the total fine, and that's what gives us our equation. Here's the fine for the novels. Here's the fine for the astronomy book. Here's the total fine. Notice that it's written in cents, 870 cents. So now we just solve this equation. 40D plus 10 times D plus 7 equals 870. We will distribute the 10. 10 times D is 10D. 10 times 7 is 70. Combine like terms. 40D plus 10D is 50D. And now we'll subtract 70 from both sides. That gives us 50D equals 800. And then we'll divide both sides by 50. That gives us D equals 16. Each of the 4 novels was 16 days overdue. And the astronomy book was D plus 7, which is 23 days overdue. So now we'll look back and see if that answer makes sense. Each of the 4 novels was 16 days overdue, and the astronomy book was 23 days overdue. Because the fine was 10 cents per day per book, the fine for each of the novels was 16 times 10 cents, which is 160 cents. Hence, the fine for all 4 novels was 4 times 160 cents, which is 640 cents. The fine for the astronomy book would be 23 times 10 cents, which is 230 cents. And if you add those fines together, you get 870 cents, which agrees with what we were given. Here's another example. In a small town, 3 children deliver all of the newspapers. I'm not sure if any of you are old enough to remember when children actually delivered newspapers. I'm old enough to have done it when I was a child. Abby delivers 3 times as many papers as Bob. Connie delivers 13 more than Abby. If the 3 children delivered a total of 496 papers, how many papers does each child deliver? So first we'll understand the problem. The problem asks for the number of papers that each child delivers. It gives information that compares the number of papers that each child delivers, as well as the total number of papers delivered in the town. So now let's call A, B, and C the number of papers delivered by Abby, Bob, and Connie. Abby delivers 3 times as many papers as Bob, so A equals 3B. And Connie delivers 13 more papers than Abby, so C equals A plus 13. Total delivery is 496 papers, so A plus B plus C equals 496. To reduce the number of variables, we'll substitute 3B for A in the second and third equations. So C equals A plus 13 becomes C equals 3B plus 13. And A plus B plus C equals 496 becomes 3B plus B plus C equals 496. So that's better. We have an equation. We started with an equation that had 3 variables. We've got it down to 2, but we really need to get it down to 1. So now the next thing we'll do is make an equation in 1 variable by substituting 3B plus 13 for C in the equation 3B plus B plus C equals 496. So when we replace C with 3B plus 13, we end up with 3B plus B plus 3B plus 13 equals 496. Combining the 3 like terms over here, we get 7B plus 13 equals 496. Subtract 13 from both sides, you get 7B equals 483. Divide both sides by 7, you get B equals 69. A, which was equal to 3 times B, would be 3 times 69. That's supposed to be a multiplication sign, which is 207. And C was A plus 13, which is 207 plus 13, which is 220. So now we have our 3 answers. Abby delivers 207 papers, Bob delivers 69 papers, and Connie delivers 220 papers. I never delivered nearly that many, I don't think. Looking back, the information in the first sentence, Abby delivers 3 times as many papers as Bob, checks out since 207 is equal to 3 times 69. The second sentence, Connie delivers 13 more papers than Abby, is true because 220 is equal to 207 plus 13. And then finally, the total delivery checks out because 207 plus 69 plus 220 equals 496. That's going to do it for section 8.2. We'll see you next time.